and we'll introduce to you Dāvis, who will talk about the exciting world of .NET dumps, memory dumps. So with that, Dāvis, the stage is yours.
Thank you. My name is Dāvis Mošenkovs. I'm Senior IT Operations Engineer at TIF Insurance, and I'll make a short introduction to .NET memory dumps and what we can do with them. This talk will consist of two, hopefully integrated parts, some theory about .NET runtime, operating systems, and computing in general, and some practicalities about using Microsoft tools to analyze .NET memory dumps and apply this theory in practice. So .NET memory dumps are actually pretty simple, and with proper tools, they are very human readable. So we won't do what's on the left part of the screen. Okay, maybe we will touch something like that near the end of the presentation, but mostly we will focus on something more readable like the Visual Studio on the right. So what's a memory dump? Memory dump is something like a debugging session saved a file. I really like this analogy because it's not something cryptic which needs like superhuman skills to read memory. It's just something that can be opened by Visual Studio and some other tools, and that can be used as something like a debugging session, but saved in a file. Memory dump is a file that contains snapshot of application's memory, or at least a part of memory. And the very good thing with memory dumps is that they can be stored for later use. For example, if there's a fix released and the fix has not actually fixed the issues, and it's possible to look into the same old memory dump again and see whether what actually happens there, and dig a bit more deeper and compare it with maybe with a newer memory dump that's taken after the fix has been deployed. Also, memory dumps can contain a lot of sensitive information like data that's processed by the application, possibly some credentials and other sensitive stuff. So memory dumps shouldn't be, of course, shared with untrusted parties. So I guess we can briefly talk about troubleshooting issues when troubleshooting options if the problems happen outside developers' machines. So, of course, the most common approach, of course, is reproducing the issue on developer's computer. When the issue is easy to reproduce, this is an extremely efficient approach, and I think it's yeah what's usually done and what's usually working very well. It has a wide range of debugging options, and if done correctly, it's pretty safe. And if the issue is easily reproducible on developer's machine, then in almost all cases, except if memory leak is being diagnosed or something like that, then or maybe resource congestion, then memory dumps actually won't be that helpful. So if it's a straightforward issue, like you click a button and thing A should happen, but actually thing B happens, then memory dumps probably are not for this situation. Probably it won't help, won't make it much easier. However, we will today talk about not so easy to reproduce issues. I think everybody has faced the situation when something doesn't work on a particular environment, either it's production in the worst case scenario or some test environment in a bit better scenario. And the same thing works extremely well on developer's machine. When you try to reproduce it with your best efforts, it just works. In such cases, when the reproduction is not available, a common thing which people does, and that's actually sometimes very handy, very good, and in other cases not so good, it's just doing remote debugging. Remote debugging, of course, has a wide range of debugging options. You can step into methods. You can do basically everything which you can do with local debugging, except you're debugging something on a remote computer like a server of production or test environment. Yeah, and in some cases, this can be a good option, but in other cases, it's not that good. For example, if the issue is happening in production and if the service, if the instance of the service which is having the issue has, let's say, it's serving 200 users, then probably you wouldn't like to pause everything for those users and do debugging there. Another issue with remote debugging, as with almost all debugging, which doesn't include uh, well known or well documented reproduction of the issues, is that the results are somewhat volatile. They are not storable and reproducible, because if a developer investigates an issue using remote debugging and thinks he knows what happens and he develops a fix and the fix doesn't work, then it's with remote debugging alone, it's not possible to return to this debug session. It will just, you'll need to wait until the issue happens again. And of course, often the developers are not available because we are all people, and if the issue happens, let's say at midnight UTC, and not every night, but in some random nights, then probably remote debugging is not the best option as well. So due to various reasons, remote debugging is often not so good option. It often has its own drawbacks, and can be very helpful in some situations and can be almost not practical in some other situations. And there's at least one more option. It's memory dumps. We will talk about them a bit more. They offer limited debugging options. Things like inspecting variables, thread stacks, etc. They should be available, especially if it's a full dump that contains all the memory. And other things like stepping into code, actually executing code, they won't be available. And that's not just a, let's say, GUI issue, because the code executing actually relies on many different things like open files, open network connections, database connections, and many more things. So it would be extremely hard to implement something like full debugging session using only memory dumps, and it would have, let's say, a lot of places where issues could arise. So debugging with memory dumps, it's usually quite safe. Although also one shouldn't like download memory dumps from some questionable websites, because probably there are edge cases where Visual Studio could execute some codes that's in memory dumps, but usually that's not the case. And usually looking into memory dumps is really safe. And of course, if you are like really want to be on the safe side, and if it's some really codes that shouldn't be executed, then of course you could just disconnect from the network while doing the troubleshooting, doing the memory dump analysis. But usually that would be just a very risk aversive precautionary measure. Memory dumps are exceedingly good. My favorite method, almost like some magic for randomly occurring issues, assuming that the issues last long enough so the memory dump can be collected. In the very best case, memory dump can be used to understand what caused the issue. In the worst case scenario, memory dump can be used to understand, well, what might not have happened. At least it very often can give some clues. And of course, memory dumps are just files. It means that if they are saved for later time, preferably together with the source version, which was used to compile that application version which had the issue, and the compilation results, including the PDB files, then the debugging session, it should be possible to just open it at later point in time, look in the very same issue again, look deeper if needed, compare it with something else if needed, give it to your colleague if needed, if you want, if you think you might have missed something. So memory dumps are exceedingly good for different reasons, and they are often actually like a low-hanging fruit, because if the application, the speed at which memory dump can be saved, it's usually more or less limited by the storage speed. And if the application is not consuming too many gigabytes of memory, then taking memory dump is usually a very fast procedure, and it can be applied before restarting many services. It's usually the time taking to just log into a server or Azure portal or invoke some command lines if you have not scripted them will be longer than the human time needed, will be longer than time needed to take a memory dump, both human and the computer time needed. So it's often a very good option to debug up some production or test environment issues or any other issues that are hard to reproduce and sometimes randomly happen. And it's almost always, unless your application is consuming like 80 gigabytes of RAM, single process. If this is not the case, then memory dump taking is a low-hanging fruit. And it's also exceedingly good option to troubleshoot some weird issues like random outages, random instability, unusual behavior, unusually high CPU usage, memory leaks, some performance issues, like you would expect the application to be running with 50 threads in parallel. But if you do the math, then you see that the performance is like 2 times better than for single threaded. So in all those situations, memory dump can also be super handy, and even somewhat handy if you are reproducing it locally. If it's a memory dump or resource congestion, when application should be multi-threaded, should run multi-threaded, but it just doesn't perform that well. In those cases, memory dumps could actually be used also together with locally reproducing the issue. But of course, whenever you have locally reproduced the issue, then if it's easy to reproduce, then you can just attach the debugger. But of course, there can be situations when in different points in time the issue is a bit different, and then saving a memory dump is again, it's helpful. And it's very important to mention that there are different types of memory dumps. There are full dumps, which are usually recommended, especially for .NET. And there are mini dumps. The mini dumps doesn't contain heap. It means that mini dumps won't contain any reference types at all. So be extremely wary with them. And there's also possible to take some dumps in between full dumps and mini dumps, but usually, unless application is consuming large amounts of memory, like more than 10 gigs, then full dumps are really low hanging fruit, really easy to take. You don't have to worry about how much time it will take and how much disk space it will take, etc. And also taking several memory dumps with small intervals between can be very helpful due to various reasons. One reason is that garbage collection might actually be running, and as Murphy doesn't sleep, if you will take a single dump, then it's possible that the garbage collection will run there. And actually, the more memory is stressed, for example, if application has stuck in an infinite loop that's just creating objects and tearing them down, creating and tearing them down, then garbage collection can actually happen quite often. Also, if you have several memory dumps, you can try to check for some differences between them. For example, does a certain object has the same address in memory or not? If it has the same address, then most likely it's the same object. If not, then it's most likely a different object. You can also check how many instances of certain type are in first memory dump and how many are in the second dump. Like, is the amount of objects of a particular type increasing? Yeah, then there's another thing that if you examine the threads, then the more memory dumps you have, the less probability is that threads will be running some random things, and the more probability is that in majority of the time you will see the threads actually in the places which consume most of the time. So for different reasons, as the memory dumps usually are small, basically size of application data plus a few, maybe 100 megabytes for the code and all that stuff. As they are usually quite small, it's recommended to take a few full dumps. Yes, they usually take just seconds to take. Yeah, and then do we have any questions?
There was one question.
Yeah, PDBs captures the build artifacts. Yeah. They are, answer is preferably yes. The build artifacts, the PDBs, they are not mandatory. You can still analyze memory dump without them, but they can be extremely helpful, especially if you want to map the memory dump back to the source code lines. If you want to like click on the thread stack and get the line in code highlighted, where the line in code which was actually compiled to that pointer, then PDBs are needed. But in majority of the cases, actually you don't need them. You can have pretty good insight of what's happening even without PDBs, even without symbols. And also there's this distinction between debug and release builds. In many cases, yeah, we will cover containers in the next slide. Yeah, but returning to this question, actually, if you know that there will be some issues, you can actually take a memory dump of a release build and analyze it without symbols. You will have some gotchas, like some methods will be inlined, and you will think, how on earth this particular method could call this method? I have checked entire version history, no calls there. But it turns out that it calls a small method, the small method gets inlined, and on the stack you see the caller method and the nested call directly without the intermediate method. But if you take into account such things, and practice helps a lot, then the symbols and debug builds, they are good, they are very handy, but they are not needed. They are not like a requirement. Yeah. Okay, then I guess we could go back to the slides and talk about how actually one can obtain memory dumps. There are many tools which can create memory dumps. If that's an application that's running on a server, like on IIS environment, or some, whatever, physical or virtual server, then Task Manager and Process Explorer can be very helpful. Task Manager is the Windows built-in Task Manager, and Process Explorer is a tool from Microsoft sysinternals that's like Super Turbo Task Manager on steroids. With them, you can just click on the process, we will do that, and choose to take the memory dump. Then there's prods dump tool from sysinternals. It's a command line tool. Also possible to get memory dumps. Also, it can make memory dumps if exceptions are thrown. And if I remember correctly, it can also take memory dumps on certain first-hand exceptions. So it can be quite useful for more advanced scenarios. And then there's Windows error reporting. It's configurable via registry, and it's extremely useful for client-side applications. If you have like an application that's deployed to some either terminal servers or user PCs or something, and you want a memory dump if the application crashes, then you can configure it in registry through Windows error reporting registry keys. And then for Azure App Services, there's a diagnostic tools section in, I think it was diagnose and solve problems. And there you can take memory dump. You will need to specify Azure storage account where to put that memory dump. And for containers, either running or Docker or Kubernetes, there's a tool called .NET Dump. It's also made by Microsoft, and it works. It's cross-platform, so it works not only on Windows, but it works also on Linux. I haven't myself used it on Docker or Kubernetes, but I think that should be possible. And most likely it could be possible even to create some Kubernetes sidecar container with some automations that would automatically collect memory dumps if the application misbehaves using some scripting. So .NET Dump is the tool, is the answer to the second question about can you take the memory dumps in containers? The answer is yes. You will need to install .NET Dump by something like .NET install .NET Dump or something like that. You can definitely find this on Microsoft website in the documentation. So .NET Dump is the tool for you. And yeah, if we return to the very manual scenario, we are taking memory dumps from just a server or a workstation. Then for distinguishing different application pools, command line field in Task Manager or Process Explorer is a relevant one, because command line for W3, WP processes contain the actual app pool name, and to distinguish different executables with the same name, the image path value is the field is important one. And for diagnosing memory leaks, the commit size is actually commit size in Task Manager and private bytes in Process Explorer are the important fields, because the working set in Process Explorer, and I think it was called something like mem usage or something like that in Task Manager, those fields will not always grow when memory leaks happen. Also, regarding taking memory dumps, if you're troubleshooting something like a memory leak, then you will be interested to stress the memory quite high. You will be interested that the leaked memory will be, let's say, 90% of the application's memory. For the simple reason that the more memory will be consumed, the more visible and more obvious will be the memory leak. For example, if you will know that there should be some transient object that's used for some calculation, and you will open memory dump, and you will know that there are usually like something between 100 and 1000 concurrent requests, and you will see that it has a million of those objects in the heap, and you will know that usually only one object is used per request, then you will know that somehow they have been leaked. And the same applies to resource congestion. For example, if you have this situation, you have a web service or a messaging service or something that should be multi-threaded, but when you load test it, you will see that the throughput for, let's say, 50 threads is just twice the throughput for single thread, then also you will be, the issue will be more visible if you will stress the component with, let's say, the 50 or 100 threads, that vast majority of them will be waiting and locking, and then take the memory dump. So inside the memory dumps, the locking and the places where the locking happens would be really, really obviously visible. Yeah, and as I mentioned, due to several reasons, possible garbage collections, ability to inspect changes, what has happened during some time window, etc., taking a few memory dumps is often preferred. Just take one memory dump, wait, let's say 5 to 10 seconds, take second memory dump. Sometimes I take like 3 memory dumps if I think that this issue might be hard to solve. But usually actually one is sufficient. But I know that if I would take only one, then Murphy would strike, the garbage collection would be running, there would be something I would like to investigate how the memory has changed, and yeah, I would run into problems. So I prefer taking more than one memory dump. So this is actually how taking a memory dump looks. Here's it in Task Manager. Just right click on a process and choose create dump file. And here is it, how it looks in Azure. Just choose diagnose and solve problems on the left side, then choose diagnostic tools panel and choose collect memory dump option. And actually regarding Azure, there's one more very important thing. Taking memory dump can be also an auto heal action. So if you have configured auto heal for your application, if it malfunctions, it gets automatically restarted. That's good. But you can add some more value to it by configuring taking memory dumps as well. Then there will be a memory dump and the application will be restarted. And as a result, the result should be that you have a memory dump and you are able to investigate, actually get some more clues what might have happened in the application. Yeah, so I guess I could now showcase taking memory dumps and then take a few questions if we will have those. So here I have prepared an example exe. Here are already a few dumps, but let's ignore those. So let's run the exe. It says something. I will mention exe on the last slide. I can open Task Manager. Yeah, I see it here. I can either click here and create dump file, or I can go to details and in the process list, I can right click on it and choose create dump file, and it will create dump file in my temp folder. One important thing, by default on terminal servers, temp folder gets deleted once the user logs out. So if you are logging in to a server using remote desktop and collect memory dump using this method, then you might want to quickly copy it to another location. Otherwise, the memory dump might just be deleted when you log off. And I have done this myself, made a memory dump, logged off, thought, now I will connect to a file share and collect the dump and analyze it and understand that, well, dump has been deleted. Yeah, so this is with Task Manager. Here's the Process Explorer from sysinternals. Actually, to take memory dump, if the application that takes the memory dump is running in the same user account than the target application, then administrative rights are not needed. But if the target application is running in another user account, then administrator rights will be needed. There's something called C debug privilege. These debug programs or something like that in group policies will be needed, and that will allow to just open any process and take memory dump of any process. Basically, it's granted to administrators group. So if you're local admins, then you have it and you just need to run Process Explorer as administrator if you're using it to capture the memory dump. And yeah, here we see just some random process. It will show access denied, but if we click on our example application that is here, then yeah, we see the information. Okay, that's unintended. So here's the example application, create dump, create full dump, and we can call it something like example1 demo. And the last but not least option, let's again, I'm running this without administrator rights because the target application is running in my user account, and I will need the PID. Where is the PID? PID is here, 34072 .net -dump collect -p, and the PID is 34072, and it has collected this memory dump. Basically, this will be the procedure of collecting memory dumps on containers once .NET Dump is installed. So it's really easy.
Davis, is it possible to make the text a little bit bigger in
Command prompt?
Yeah. You show?
Sure. I will try my best. It might be this thingy, and font size, let's set it to this one. Now it should be more visible. So .NET dump collect and -p, and then there was this process ID, which was, I think, this one. Yes. And this was the command line. Once .NET dump is installed, this is how easy it is to collect a memory dump if process ID is known. This would be the procedure on the containers. Good. So maybe time for some questions again, if we have those. I don't quite get the idea. If 50 threads don't work, perhaps 200 will. If that's a joke about concurrencies, then it's a funny one. Yeah, because people often think that they can just increase the number of threads without looking into numbers, and then at some point they realize that, well, the performance is order of magnitude smaller than it should be. And if it's about diagnosing, if it's about stressing the application before taking memory dump, then then also if you have stressed it with if it's about stressing application with memory dump before taking memory dumps, then if you don't see, you need to have like let's say at least 90% threads waiting. So if your application is actually capable of processing in parallel 50 threads, then of course you will need not 200 but maybe 500. And if your application is capable of processing in parallel only 2 threads, then I think 20 will often be enough. But better a bit more, because there will always be some threads which will do some unusual stuff. Yeah, I will show those. I will show analyzing dumps. So I guess I could probably return back to the presentation. Yeah, about analyzing the memory dumps. There are many tools. We will focus on Visual Studio, on WinDBG a bit on PerfView. And then there's .NET Dump Analyze, that's very similar to WinDBG. And there are maybe at least one other from Microsoft. And then there are some third-party tools. I haven't used them, at least recently. Maybe I have used .memory many years ago, but I don't remember it precisely. So before starting with the actual hands-on things, let's repeat some boring theory. At first, processes are the things running. Threads are the things running, and processes are just containing threads, and memory is that's shared between the threads, and some other things. So we take a memory dump of a process, and it will contain all the thread stacks and all the heap, and of course this memory, it will be virtual memory of the process, and it's shared between all the threads in that process. And unless some special things are invoked, then it's not available to other processes, of course. And then there's an important distinction between managed MSIL and native code. The actual CPU instructions running, we will focus on managed debugging. It's a lot easier than unmanaged. So when opening memory dumps with Visual Studio, we will actually, it will prompt for us what type of debugging we want to do, managed, native, or both, and we will just choose managed. Unless you are working with some issues involving unmanaged resources, usually invoked through some third-party libraries, unless issue is something like that, or you are suspecting issue in the framework itself, unless that's the case, then managed debugging will be the thing, will be the only thing needed. And then there's this important distinction between reference types and value types, because thread stacks is actual memory, a piece of memory allocated to each thread, will never store reference types. It will only store pointers to them. And that's one of the reasons why it's always preferable to collect full memory dumps, because they will include the heap which has the actual objects. Otherwise, you might just see that, okay, on the thread stack you had this object, and you will have no clue what's actual field values are, etc. So heap is important. Heap stores all the reference types and also static variables and stuff like that. Yeah. Then there's debug builds versus release builds. I already, I think, mentioned this, that debug builds will contain a bit more information. So they are preferable, but not required. And the biggest thing, which I think one should vary when debugging release builds and analyzing memory dumps of release builds, is in method inlining. If you see some weird method calls, then very likely it might have been inlined. Yeah, I guess one option might be actually decompiling the compiled application to check for inlining, but I actually don't remember doing that. So there might be dragons on its own. And then there are symbol files that are also preferable, but not required. Yeah. So symbol files, PDB files, the build artifacts, it's good to have them. And if you will have the exact source code, exact PDB files, and the memory dump and the exes themselves, then you should be able to do something like analyzing the memory dump. And actually, when you will open memory dump, you will be able to just click through the code. You will be able to like click on the thread stack and see the exact point in code where that method was called. So these are valuable, but not required. Do we have any questions on this? Yeah, I guess not so far. So I guess we can proceed with more boring theory. Yeah, this will be a bit more complex. This will be about two types, for which memory dumps are really handy, really valuable. One is resource congestion, the thing which I mentioned, where you have theoretically multi-threaded application. Practically, you see that different requests actually get processed by different thread IDs. For example, in the logs you check thread IDs, they are different. Everything looks good. But if you check if you check the actual throughput data, you see that, well, the more threads you have, the more requests you're running in parallel, the slower each request on its own gets. This is, let's say, typical nightmare in typical vertical scaling. You think that you can just add more, just change some magic number of threads somewhere, everything will become faster, but actually it doesn't. And a very notable example is actually .NET's HTTP client. By default, this is a simplification of only 2 parallel connections. There was a bit more complex logic, but in very many cases, by default, one instance of HTTP client can only make 2 connections in parallel. So what will happen is that all other threads will just block and wait until one of those 2 connections gets freed. And that's a very, very simple to diagnose congestion point using memory dumps. You would just see that all the threads are waiting on that HTTP client object, and you will see that they are doing some, I don't remember what exactly, but they are doing some locking. They are not waiting for network IO or anything. And then there will be question what's happening, and it turns out that there's this default limit which can be changed, but which is documented, but not in let's say many enough places. So I guess many people have stepped on this issue. Yeah, so that's relatively easy to diagnose. You just load your application until you see that it's behaving like 10 times slower than it should. Then you take the memory dump and then you check where the threads are. And in most cases, they will be waiting on a bottleneck. And then depending on the situation, that bottleneck can be improved, of course. And then there are much harder to diagnose issues, as these are race conditions. A race condition is basically when 2 things happen in parallel in the quote unquote wrong timing. When, for example, the textbook case would be 2 threads which want to increase the same variable in memory. Let's say the variable contains number 5, and each thread should increase it by 1. In the best case scenario, first thread reads the memory, increases, puts it back. Second thread reads it, increases, puts it back, and you get the value of 7 as you should. But when the Murphy strikes, both threads would read the value of 5. Both threads would simultaneously in parallel increase it to 6. And both threads in some order would actually write that 6 back to memory. So that's when you get some weird behavior. And those types of behavior can be really hard to reproduce. They sometimes can be hard to understand even when looking at memory dumps. But often they are very, very easy to diagnose using memory dumps, because these type of race conditions can cause memory corruption. Very, very straightforward example is writing to system collections that are non-thread safe. Yeah, but of course that applies to any non-thread safe object. For example, if you make an object in memory and that object can be accessed by multiple threads, it's always worth thinking about how it will work with multiple threads. It's something like, not entirely like David's idempotency thing, but it's like microscopic version of that one. It's inside single process, but still, if you are sharing an object between threads, then if that object is something like a cache or something, then there might be dragons. And such dragons are this memory corruption. Actually, .NET System Collections have thread safety section in the documentation, and that's something I think it's extremely valuable to always pay attention to and think whether this collection can or cannot be used for multiple threads at the same time. And in worst case scenario, when there are several parallel writes to a non-thread safe object like a collection, then it can corrupt the collection and it might do some different things. One example is it might actually stuck in infinite loop because the collection internally it will have something like linked data structures. And if there's infinite loop on those links, then instead of just visiting each node once and afterwards seeing null and or some other indicator and then just aborting and assuming that collection doesn't have this particular value, instead of that, then looking up a value in collection can cause infinite loop. Of course, infinite loop will again be extremely easy to diagnose with memory dumps. You will just stress test the application, see that it locks up. You will know that now you have many locked up threads. Then you will analyze it in Visual Studio, and you should be able to see that the threads are locking up in a certain place and inside dictionary. And basically, if you see many threads in dictionary and you check that it's the same instance of dictionary or that applies to any non-concurrent collection, then most likely the memory corruption has occurred. But there are also other cases. It can also throw exceptions and do other undefined behavior. And in some cases, it's as easy as checking it from Visual Studio and saying, yes, we definitely have a collection. It's non-thread safe. It's used by multiple threads. Cool. We need to change that to a thread safe collection. But in other cases, it might be more messy. Some automation might be needed. And there's, of course, an edge case when there's only one concurrent write and at least one concurrent read, and that read does not read what it should read, and either throws exception or reads something else. That's extremely hard to diagnose, even with memory dumps, but it can happen. It can happen. Of course, looking at the code can be very helpful. And actually, regarding these exceptions, I remember a case where HTTP client, there was an HTTP client instance and multiple threads tried to add headers to it, request headers to it. And it ended up with all the requests to that particular web service which has this issue throwing exceptions. And it turned out that HTTP client, the headers collection is non-thread safe. So headers should not be simultaneously modified from multiple threads. Yeah. Do we have any questions so far? I will then go to Visual Studio and the very practical part. This was the, let's say, hardcore theory. Good. Then no questions about theory. Awesome. Cool. Yeah. Then the analysis techniques. Visual Studio. Actually, this is the super important part. It has something called parallel stacks window, where it shows how many threads or tasks are in a particular place in code. This can be extremely useful to troubleshoot in, let's say, a lot of issues, especially if if these methods are something new in the project. In many cases, if there's either the application has locked up or if it's super slow, if there are parallel requests and they are not getting through something, if they are not processed, then very often just looking at the parallel stacks window will pinpoint where the problem is. If you are using asynchronous programming, then it could be very similar, but only instead of threads, you might need to use tasks, assuming that it's not stuck into executing a real code, but it's actually waiting for something that might have not provided the level of parallelism that it should provide. Also, beware of scapegoats. We will have one in next slide. It's basically the idea is that the executing method on top of the stack is not always the problematic one. Maybe it's an innocent method. Maybe it's called from a wrong maybe it's called many times. Maybe it's called from an infinite loop. Maybe it's just used wrong as it is with dictionary, because dictionary itself, it's working properly. It just shouldn't be used from multiple threads at the same time. Another tip, practical tip, is disabling just my code. That will allow to see full managed stacks. It can be handy if you are using many different third-party libraries. Yeah, then of course in Visual Studio you can switch the threads from the parallel stacks window or from threads window. You can navigate stack frames. Then you can use make object ID to identify objects. As far as I remember, Visual Studio doesn't show memory addresses, but you can use make object ID, and then you will see that, for example, if you see that many threads are accessing a dictionary, and if you will make object ID on one of those threads, then you will mark this particular instance of dictionary in the memory, and then if you will examine call stacks of other threads and sees this exact dictionary, then you will know that it's being accessed from multiple threads. And of course, Visual Studio is, let's say, quite user-friendly, quite human readable. Have proper symbols, proper source code version, and I think proper executables as well, then it should be possible to have limited version of the same comfort as debugging locally. You can click on a thread, a call stack, see exact point in code which was executed, and of course, as it's a memory dump, you won't be able to execute any code, step into methods, etc. So this is example of a scapegoat. It's just a method, a problematic method which has infinite loop, and the scapegoat method which is doing something. And as this method either will get inlines this problematic method, or at least it will be extremely fast, then CPU will always be in the scapegoat. And the first impression might be that, well, scapegoat is doing something problematic, but actually the problem is somewhere else. A method just gets called repeatedly. Yeah, so I guess we can go to some questions about this file, and then we could look into Visual Studio, or maybe I could, yeah, I guess I will show Visual Studio and then go to the questions part. So let's run Visual Studio and open the memory dump which I just collected. In this case, I intentionally click no code. I could actually rename this folder, so I won't have source and symbols locally. I will have only the memory dump. Yep, the memory dump, and let's click open. Just file open in Visual Studio. It's that easy. Just file open, file. And then let's look at the memory dump, which is 1905 something. This is one which we collected using the .NET dump collect command. And here Visual Studio prompts us what type of debugging we want to do. We want to do managed only, because we are not interested into the native code. We click on that. It says that it doesn't have symbols for this particular thingy. And then we can click on parallel stacks window. If it's hidden by default, then one can enable it, through debug windows and parallel stacks. And here we see that actually from 50 threads, 49 are waiting somewhere here. And one is actually calling this data processor. So of course, this is just a same example application. Actually, I won't dig into details here, but unless...
Davis?
Yeah.
Have you the possibility to zoom in again?
Yeah, sorry.
Thank you.
Probably something like this. So here we see that there are 50 threads, 49 are somewhere waiting on a lock, and one thread is actually doing something. So most likely somewhere here, we have some locking. that might be subject to optimization. Yeah, this is actually example application. I'm not planning to dig into that, and I have published those on GitHub. So I think these should be quite decent like exercises for memory dump analysis, and they contain also at least one of solutions, at least the one which I had in mind when made them. So yeah, and of course here we can inspect local variables for the threads. We can inspect call stack. If we would have all the symbols in source code, we could jump to source code, and I'm not sure what will be here. Yeah, the same objects more or less. But the idea is that this is basically a debugging session, and one can, for example, make an object ID. This is, let's make object ID, and then this will have the object ID, and we can, let's say, click to another thread, and then we will see that this variable, it's a different instance. So we are not reusing that type. So this is basically a limited debugging session. Yeah, now I guess the question time. Yeah, I guess main message of this part was that this is basically a debug session. That's simple. It will be limited. For example, I won't be able to do anything like continue, not supported, or step into a method or something, but still I can view threads, I can view call stack, I can examine many different things. And for this parallel stacks window, there's also selection for tasks. This application shouldn't have any, but if there would be tasks, then they would be displayed here. And it beautifully groups tasks or threads together. Cool. So I guess we could return to the slides and go to a bit more advanced technique. It's yeah, WinDBG. This is very close to that hex editor from the first screenshot, but it's super powerful. It can be used, for example, let's open the same dump in WinDBG. I have installed WinDBG Preview. It's a newer version of WinDBG, and it will allow to do things like list all the variables with a certain type. Okay, I will need to manually write that command. I can actually write a bit different command. Okay, so in WinDBG, it will not be open file, it will be open dump file. And then let's browse for another thingy. Let's open another dump collected by .NET Dump, because that one might be locked by Visual Studio. Let's click open. This by default will start with unmanaged debugging. We will need to invoke this first command, dll -v -u -l. And now we should get managed options as well. And here we can invoke these commands. As I said, these commands will be, this WinDBG is quite similar to .NET Dump Analyze. I haven't used .NET Analyze much. I have used always WinDBG. And yeah, here we can also the threads. Oh, sorry. Yeah. And we can also do things like memory statistics. I haven't found this option in Visual Studio. Then we can click around. For example, we see that it has some strings, quite some strings. We can click here. and we will see addresses of the string objects, and we could click on any of them and it would invoke another command, and that would display the string is a.d. and another string it has just char count. Okay, so, and what is this long string? Yeah, it has some longer value. So we can inspect memory contents using WinDBG. It's basically more of a, let's say, Googling thing, and it's extremely powerful. And the power actually is in scriptability, because it contains simple commands like for each, if, etc. Then it contains these commands which look like really super hard, super non-intuitive, non-understandable, but actually they can just be used to reference fields of objects. For example, if we have something that resembles a structure, some kind of structure, probably abdomen will have many fields, and it has one instance. Yeah, then for each field we see the offset, and actually to this object's offset, adding this offset, they are hexadecimal, and referencing pointer in that place, we actually can access this property in WinDBG scripting. And it's not super hard, it just looks hard. And it if you will need it, then it will be quite just some time needed, and then you should be able to find it, let's say, some instructions online on how to do that. And for example, this particular script, it takes an object, it references it by method table because that uniquely identifies a type, and then it dumps all the sub-objects referencing field inside the field. So in this case, it just printed out URLs that were processed by a particular W3 WP process dump. And this can be used if you have something like, let's say, 1,000 ongoing requests, and you want to find a certain variable in, let's say, maybe one of them, maybe 5 of them. If you will manually go through 1,000 requests, 1,000 tasks, 1,000 threads, 1,000 something, then it would be quite waste of time and also quite risk of human error. WinDBG allows to automate these things. So WinDBG is basically for scripting. Yeah, and I guess this, let's see whether we have any questions regarding WinDBG. Not so far. Okay, then let's continue. Next slide will be again much easier. No weird commands, just a nice GUI interface. This is PerfView. It's another tool from Microsoft, and it's, let's say, the best free tool I know at the moment for troubleshooting, for visually troubleshooting memory leaks. It allows not only to troubleshoot memory leaks, it can also allow to profile for log garbage collection events, as performance counters don't always update properly, and do many more things. But here it's just a screenshot with PerfView. We have opened an application. The application had a memory leak, and here we see that the memory leak, it has something to do with inversion of control framework with Castle Windsor, and it has to do something with some particular types. Yeah, I guess we could run PerfView and open one of the memory dumps. Let's open this example demo dump, which we collected with Process Explorer. This is take GC dump. The GC dump, actually, it's a kind of subset from the memory dump. And GC dump file afterwards can be also opened by Visual Studio, but It can be opened by PerfView itself. And here, for example, we can click on reference 3. And here we see how much memory something uses. And one of those examples is actually, I will, I guess, mention them in next slide. One of those examples will be troubleshooting a memory leak, and it should be very clearly visible here. When opening memory dump with PerfView, choosing collect GC dump and then clicking on reference 3, that should be quite notable which type consumes the memory. Yeah, so I guess it's the last slide. Thank you. And this is the URL to those examples. I think they I hope they could be handy. I hope they could be handy. And I guess short takeaways from this presentation could be: don't use non-thread safe collections and actually objects in general from multiple threads simultaneously. And it's always worth thinking about when you are designing objects in your application. It's always worth thinking, giving a thought on, will that be accessed only from one thread, and how it will be with concurrency. And take memory dumps before restarting things. They can be taken on servers, on Azure App Services, on Docker, Kubernetes, and many other places. And there are plenty of tools doing that. And I would, of course, like to stress .NET Dump, because it's cross-platform and useful on containerized environments, and also Azure Auto Heal. And of course, on servers, it's just plain old Task Manager or Process Explorer from sysinternals. But there's actually a bug in Process Explorer that sometimes for some .NET Core applications, it might not be able to take full dumps. And in such situations, at least some of them, Task Manager was able to take the memory dumps. Yeah, so, and analyzing with Visual Studio is very similar to regular debugging. It's just open Visual Studio, choose File, Open, choose the memory dump, and then click on Managed Only Debugging. And it will be a sort of restricted debugging session. That's simple. And WinDBG, it's much less intuitive. It's a command line interface. It supports clicking around, but it's extremely powerful because it's scriptable. And if you will have many hundreds or thousands of objects and you will need to find a needle in haystack, then WinDBG might be the tool for you. Thank you. Yeah, if we have further questions.
I don't think there are too many new questions, but I had one just because I'm curious. Do you know which studio version do you need to have in order to open those memory dumps? Is it professional, or do you need a higher version?
I think professional. I think I'm using professional actually. I think that community edition also was enough. I don't remember. Yes, it's professional is definitely enough, and community edition might be enough. I think I have also tested community edition a while ago. And one thing actually to bear in mind is that sometimes if memory dump is not working properly, then updating Visual Studio might solve the issue, because I have had those issues. Installing Service Pack just miraculously solved problems.
Well, that's good. No longer having to buy the most expensive Visual Studio in order to do a bit more technical debugging.
Yes.
So that's good. I thank you for a very thorough, I wouldn't say just an introduction, I'd say this was a pretty nice and thorough step into the .NET memory dumps world. So big thanks to you for sharing your thoughts and ideas about how we can debug our .NET apps. And we're a bit short on time, so if there's no other questions, Oddbjørn, I don't know if you have any other messages before we sign off.
I can't see any questions now. So seems like that's everything.
Well, in that case, I think on behalf of me and Oddbjørn, and also a big thanks to Dávis and David, we'll see you in 2022. Thanks for watching. Bye-bye.